There you go. Something new. No countdown anymore. All right, we ready to rock and roll? Taking CSSTP. One more step. One more step. Hi, I'm a proportion. What are you going to do to solve that? Name two variables you'd multiply together. A and D. Did you ever know they have special names? The numbers or the variables you put in A and D spot have a name. They're called the extremes of a proportion. The numbers or the variables you put in for A and D are called the extremes. And the other two you would multiply are B and C, and those have names as well. Those are called your means of a proportion. Means. And I always get, well, how do you remember which one is which? I really don't have a tricky way other than A and D, extreme downhill skiing. Okay, we'll leave it at that. Extreme downhill skiing, left to right. Okay, good talk. I can tell you like that a lot. What do you do with A and D? What are you doing with them? Okay, you're multiplying them. So when I figure out the answer, if I multiply, anybody know what I call that? The answer in multiplication. Product. So here's the theorem. Product, which tells me I'm multiplying them, the product of the extremes. And what are you doing when you go to the means? What are you doing to the extremes and the means? You set them equal to each other, right? So product of the extremes equals, how am I going to finish this? Product of the means. Got it. But to say this, you need a proportion. Yesterday, how did I get a proportion? What allowed me to write the two ratios were equal? Proving the triangle similar. And then what was the reason for the proportion from yesterday? Oh boy, hasn't been that long. C, SSTP. So everyone see what we're doing. We're still going to prove triangle similar. We're going to set up our own proportion by CSSTP. And then we're going to cross multiply and say the extremes and the means are equal. Adding one extra step to yesterday's proof. Now, I know some of you guys are clever. You're sneaky. Any way you can find a shortcut, you will. I will let you know right now, if PO equals POM shows up in your reasons, not going to be accepted. Okay? Everyone got that? Means and extremes, PO equals POM. We don't roll that way. Okay? That's not a shorthand I allow you to do. Okay? Oh, product of the extremes. Okay, okay. People are still ready. PO. Extremes. POM. P-O-M. Good? We good? That's where I was talking. Oh, yeah. You still don't know what I'm talking about. All right. All right, let's try it out. First proof here. Everyone take a look at my proof statement. Notice how I'm multiplying the sides, which tells me this is a means and extremes problem, but nothing matters until I do what? I can set up a proportion, I can cross multiply, but none of that's true unless I know what? What triangles are similar. And look at my diagram. Oh, lovely. Look at all those different triangles. Can you find the ones I need to prove similar for me? How? Use the proof statement. You need a triangle with ER in it. You need a triangle with AD in it. And then you need one with TE and DT in it. Find them now. Find them. Find those two triangles, and then we'll prove them similar. Did you find the triangles? Please relay that info to the class. Oh, let's start this party off right with number 6. Triangles.
AD
ADT is the first one, proving it similar to RET. There we go. There are the two triangles. And then how are we going to prove them? By what method? Prove them similar by? Angle, angle. All right. So where's the first pair of angles? Where's my first pair of angles up here? 1. Got it. You went the hard route. Nice. Respect. There you go. Those two angles. Angle. I can say angle R, right? Yeah. Angle R congruent to, I'm not saying angle T though, ATD. Yeah. Why are those two? Yeah. Whew, 12. Yep. Or you could say isosceles triangle implies, what type of angles are those? Base angles congruent. In a triangle, congruent angles are across from congruent sides. And where's the second pair? Don't make this too difficult on yourself. Where's the second pair of angles here? 19. And you're welcome. I already told you they're right angles, so you don't need to put that in your proof. You just need to tell me they are congruent. Right angles are congruent. All right, what do I know about my triangles? Similar, all right, and then I'm going to slow it down a little bit. So triangle ADT. Please make sure you put the similar sign tomorrow. ADT and TER are similar by angle, angle. Okay, and then I'm going to stop right here and slow it down a little. All right, now you know the triangles are similar. You don't know the means and extremes yet because you don't even have a proportion to say that. That's the next step. Are the sides now in the same ratio? Yes, they are because the triangles are similar. Now, though, you need to write that proportion by yourself instead of just copying the proof statement from yesterday. And I'll make this easy on you. Use your proof statement to build the proportion. What's the first side in my proof statement? Side ER. That's got to go somewhere. I don't care where it goes in your proportion. All right, it's got to go somewhere. ER. All right, what's the next side, though? AD. That's important where that one goes because it's got to get multiplied with ER. So where does it have to go in mine? It's got to be the other extreme on mine. It can't be right underneath. There's no way I'm going to multiply it. Everyone see that? Okay, the only way I'm going to multiply those two segments is if they're diagonal from each other. They got to be means or they got to be extremes. And then TE and DT, wherever you'd like there. Build off of yesterday. Why is the sides in the same ratio? CSSTP. If you want to use it tomorrow, make sure it's in the correct order. A lot of people flip the P and the T for some reason. Now comes the extra step for today. Now multiply your means and extremes and tell me they're equal. ER times AD equals TE times DT. Product of the extremes equals product of the means. Okay, notice this three-step sequence right here. Notice it, all right? You can't just skip over to the means and extremes without having the proportion by CSSTP, okay? How do you feel on that? Because now you're going to do a lot of work on your own. Feeling all right? All right, second one here. That took a while. I see in my proof statement you're asking me to multiply sides, so I'm thinking means and extremes. First thing, though, I got to find the triangles. Which two triangles up here are you going to prove similar? So I'll give you a minute. Go ahead. You can talk it over with people around you if you want. What two triangles are going to be proof similar? So I get QCQP and AQCR. What's it going to be? What two triangles? Got the triangles for us? What triangles did you find? Oh boy, 5. What do you got for me?
Triangle
QPA, this little sucker right here, yep, along with triangle,
QRC.
the big dog, QRC, yep. All right, let's prove them similar. The only thing you know is it's a parallelogram, so it looks like we're going to be using a couple properties here. So go right ahead. Can you find two pairs of angles in those two triangles to say they're similar? Here you go. Use your parallelogram facts, talk it over with each other. You got this. Dig deep. I'll get back to you in a couple minutes. Finish up your last couple steps. All right, so there's a couple ways you could have went with this. First way, let's get you could have said the opposite angles were congruent because, where are you? Parallelogram implies opposite angles congruent. So you could have got SRQ congruent to SPQ. There's a pair. Okay, now the other pair you needed was alternate interior. So let's just go over this because there's certain things you need depending on which angles you picked. So let me first talk about RQA. If you said RQA was congruent to QAP, those two. If you guys told me those two were congruent, you needed to tell me beforehand in the step above RQ and SP are parallel. Cannot just go right to saying the alternate interior angles are congruent. Okay? All good. So that's one pair. The other pair, and if you said parts of parallel lines are parallel, that's fine. That wasn't needed here, though, but it's fine. The other pair, if you said angle C was congruent to CQP, you needed to say that RS and QP were parallel, and, ready? You needed to extend RS to RC. So if you chose these pair of alternate interior, you did need to say about the extensions. Okay, you did need to mention the extensions there. All right, so here is everything you needed depending on where you went. Okay, you needed some set of parallel lines either way. Questions there from you guys? Anything you want to ask? And then you got angle, CSSTP. Stop. Look at your CSSTP step if it's written down. Do you have QC and QP in places where they are means or extremes? Do not have them right on top of each other. They need to be means or extremes there. Questions from you guys there? And the last thing I wanted to do with you guys today was make sure you can do the algebra. All right, without me standing up here and calling out your numbers. So I need you to go to the homework for me and try out number 4. I got to make sure you can factor and or use quadratic formula correctly. Finish up the proof, though. Finish up the proof, and then go to number 4. sure you match up the sides. Small triangle to big triangle. Okay, make sure you're setting up the correct proportion. So you should be cross multiplying. Well, your means or extremes should be x plus 6 and x plus 1. And then your other set should be 4 and x. That's what you get when you combine AD together. You get x. The ones cancel out. It's x minus 1, isn't it? Yeah, x minus 1. I don't know where that came from. One jab. There we go. So plus 5x minus 6. So either way, factor or use quadratic formula on x squared plus x minus 6. I'll give you guys time if you haven't done so. Factor or quadratic formula. I'll give you the formula on tomorrow. All right, let me go over both ways real quick. If you ended up factoring two numbers that multiply to 6, negative 6, but add to positive 1, x plus 3 and x minus 2, so you get x equal to 2, x equal to negative 3. Tomorrow, only if there's a diagram. If there's no diagram tomorrow, you accept both. Okay, but if there is a diagram like it is in this case, what's the problem with negative 3 on AB? It's going to be negative 4. That's impossible. So you're left with 2. You guys that did quadratic formula, fine. But you got to know what's going on. X equals, you should have gotten to this point, negative 1 plus or minus the square root of 25 over 2. And this is good for everybody too. What's the square root of 25? Yeah, don't pull this. Oh, I got to break down 25 into this. And no, you don't. It's already a perfect square. So it's going to be negative 1 plus or minus 5 over 2. And then where do my two answers come from? X equals negative 1 plus 5 over 2. And negative 1 minus 5 over 2. You're still going to get the same x values we got. But that's it. You don't, if it's already a perfect square, you don't start trying to break it up. All right, you can't. All good? So we're all good tomorrow. I'll go over the homework, any questions that you have, and then we'll start up that quiz. All right, stay Stay after today if you need any extra assistance, specifically on quadratic formula factoring. But it's not, you should not be writing means and extremes tomorrow on there, okay? Something's wrong if you do. CSSTP is as far as it goes tomorrow for the test quiz. All right, good work.